we good to go?
Are you ready?
Are you ready?
We good?
Okay. No. I think it's because we're just connected.
This is
I think there's
the switcher's not working.
The presenter's not working?
Oh, are we might be in the wrong window.
You are.
Okay. Okay,
There
cool.
you go. Hang on a second. Okay. Working? Okay, perfect.
Hello, we are team JohnTownsendRamirez from the Oswego East High School Engineering Design and Development class. Our group was formed together because of our mutual interest in environmental sustainability and recycling. So we will take you through our process of this whole design process of how we thought of the problem, how we researched the problem, and how we developed our products up here.
This is our table of contents. This is what we are going to be looking at throughout the presentation, but you'll see more of that as we move on.
All right, so as you heard Mark say, our main issue was environmental sustainability. Through all of the research that we conducted that we will go into further later, we were able to figure out how we could have an impact on the recycling industry and fix some of the many inefficiencies that we found were very present and very harmful in the recycling industry.
So let's talk a little bit more about this problem. In the US, about 35.7 million tons of plastic gets generated annually, but only 9% of that gets recycled successfully. Data from the Environmental Protection Agency shows that plastic use and waste are both on the rise, and chemicals and fumes that are a byproduct of this are harmful not only to ourselves, but to our ecosystems. A big cause of this is the lack of understanding of how to recycle and also access to recycling services. So our goal is to increase the efficiency in the recycling industry.
As part of our research, we wanted to look at different solutions that have already been created and exist within our idea of recycling and efficiency. We wanted to look at these previous solutions not just to see what exists or what we need to make sure that we don't accidentally copy, but to also kind of expand the style of brainstorming, the way that we think about that process. So up here we have 3 different styles of previous solutions. On the left, we kind of have a logistical flowchart of how a patented machine would organize different plastics. In the middle, we have a diagram more like of a modeled version of a machine that's patented that would clean and compress plastic bottles specifically to be recycled. And on the right, we have like a fully fleshed out in-use machine that organizes all types of trash within some of our local recycling plants. So we have different stages of the design process of solutions that exist that we can think about and improve upon and use during our research.
All right, so for our market research, we surveyed many people. We put an online survey on many public forums. We categorized our responders by 4 different categories, which were age, region, whether or not they recycled, as well as whether they lived in a rural area, suburban, or urban areas, because we know that recycling practices can differ greatly among different types of communities. And we were actually able to find significant differences in these different categories of how people viewed recycling, practiced their recycling, and how communities handled recycling. We used our research to kind of narrow down who our consumers were so that we knew who we were looking to sell to, not necessarily, but more like who we wanted to make the product to serve. And we were able to find our target consumer and figure out what they preferred and how much money per se they were willing to spend extra to buy a more sustainable version of a product.
We wanted to aim whatever we made first locally, so we looked for local results. When asking urban and suburban residents how much they value or how much they see the importance of recycling and sustainability, both answered around the 3 to 5 range on 1 to 5 scale, giving a more left trend to the graphs. Given the purpose of our project, this was a more positive result, and it also showed us that the want to recycle isn't an issue, but rather the how to do it is.
So here we have a couple pie charts of the access to recycling. When we're thinking of solutions that have to do with recycling and efficiency, we often take it for granted that we have a recycling service here. But looking at these graphs that we created, we can see that there's actually a pretty decent disparity in the access to recycling services that different urban, rural, and suburban areas have. So from the data that we collected, we can see that if we wanted to create a solution that incorporates the recycling like services that we have here or that are run by the government or by private organizations, we want to make sure that it's also similarly suited to the type of area that these consumers would be living in, that being urban and suburban, having significantly more recycling services than people in rural areas. So we can take that into account when designing our products.
So for some other survey results, we also gauged how much these people, separated by age, again, valued sustainability. And what we see here is that there is a significantly higher presence of some lower ratings of value, the younger you go on the age scale. So, but it is largely green. So we were also able to kind of confirm the fact that the people that we were surveying and our target consumers did actually care about all of the purpose of recycling. We also saw that most people rated themselves at about a 4 on how informed they were about recycling, which really just goes to show that there's a lot of growth that can be done and a lot of consumer education that can happen because a lot of people don't view themselves as informed as they could be about recycling.
So before we decided on what kind of product we wanted to make, we first developed a consumer profile and divided it among 6 different categories. For age, we said we wanted to target our consumers around 6 and over to encourage household participation. For occupation, we said any to emphasize that we were targeting to any type of consumer. For household income, we said 50K or more, and also for the same reason we wanted to emphasize that our target customer is anyone except in extreme cases. For lifestyle, we said that they needed to have an average or above average consumption of commercial products. And for motivation, we said that they needed to care enough about the environment to purchase the product.
So far, we have talked about our personal research that we've been doing on our own with the internet. We talked about our market research. So we reached out to other people in the community and found through forums locally and online. Now we are going to talk about our correspondence with professionals in the recycling industry, people who have a lot of knowledge about what are the real issues or what things can are overloaded in terms of like media, or to really put a professional perspective on the problems that we're facing.
So our first contact was Ms. Joy Rifkin. She is the sustainability manager at Lakeshore Recycling Services, which is one of the primary recycling services that is not government run and takes care of like the Chicagoland area. So if you look around, there will be like plenty of things labeled LRS around here. So they do take care of this region. So some things that we learned from her that we weren't as able to get from our other research was that items of specific size cannot be recycled. So items typically smaller than a fist will, even if you throw them in the recycling, they will largely end up in the landfill. Soft plastics that smash go in the trash. Those plastics are also not recyclable and are another thing that will end up in the landfill, whether or not you throw them in the trash or the recycling bin. And she said that in her opinion, one of the biggest issues that we see in the recycling industry is consumer education. She said that a lot of the problems that are seen within the industry is a result of consumers not knowing that they can't recycle small things, so that they can't recycle soft plastics, or that they need to clean things before they recycle. A lot of it points back to consumer education in her mind.
Our second professional was Seth Herring, who is a plant manager at Copper's Inc. Stigma Plant. We hopped on a call with him and we discussed how different materials require different processes to be manufactured and recycled. We talked about what materials cause the biggest issues in this industry, and we also talked about how the necessity for sustainable and eco-friendly approaches are on the rise, along the rise of plastic waste and other.
So now with all the research and all the information and all the correspondence we had in that first section, we can now finally move on to brainstorming. All of the research that we've done not only allows us to just think of ideas, we can write them down on a piece of paper, but we can also style the ideas and figure out the best way to organize them to best come up with an idea that we're all happy with that is the most successful in our project.
So some things from my engineering notebook. I focused mainly on consumer side solutions and did have one industry side solution. I was thinking of reusable baggies, but we ended up not really developing that idea because we couldn't really figure out a way to innovate upon what reusable baggies already existed. There was also the idea for a metal replacement for cling wrap. As you know, tinfoil and cling wrap are largely exchangeable, except tinfoil tends to be much less durable. It can tear very easily. And I wanted to figure out a way around that. But my main industry side idea was a polyester repurposing machine, because so many of your clothes are made of plastic and those can't be recycled, but if they go in the trash, they end up in a landfill, and then there's microplastics in the ocean, as they never really degrade. And so that would allow for us to remelt 100% polyester clothing into a solid grip of, it is PET plastic, I believe that it's made of, and that would be able to be recycled. So instead of sending your clothes to the landfill, you would melt them, reconsolidate as a plastic, and then send that to be actually recycled and reused.
An engineering notebook is something for engineers to professionally document everything they come up with, from brainstorming to the actual final products. So that's what we use to document our initial concept ideas. I focused on reconfiguration of materials and filtration through my design because of feedback we got from Ms. Ripken. So some of the ideas I came up with was filtering recycling bags for recycling bins, filtering recycling bin with a grate at the bottom to filter out the small plastics or small materials, a compressor for soft plastics since they take up space, and then a melting machine to melt down small and soft plastics to create a larger, bigger plastic that can be recycled.
During my brainstorming process, I wanted to better organize a list of ideas because I knew that there was going to be a lot of them and that we needed a way to kind of show what each idea was capable of in reference to our problem. So on the left here, I have 4 categories, kind of representing the 4 different things that we're thinking about and with discussing our problems with like our professional correspondence. We had size, shape, material, and education / effect. So using these four categories, I kind of organized different ideas I had. Just running through a couple in education. One of the ideas I had was for a smart trash can that would kind of detect what type of material or what size is going into the trash can, and they could gamify the process of recycling. So young kids could put in, let's say, an aluminum can, and it would give a certain amount of points because aluminum is very, very recyclable and is very prized for many recycling companies. So in that way, it could teach, not just like tell the people who are recycling, and this could be in a household. Another idea I had that was in the size category was, well, a lot of plastic products are too small, as we discussed with Ms. Rifkin, to be recycled. If we could take a way to make those products connect to each other and build up and up and up, maybe we could get them large enough to actually be successfully recycled.
So our final three concepts were the polyester repurposing machine that I mentioned that would reconsolidate clothes into a singular brick of plastic that can be properly recycled. And then the filtering and recycling bin was Adam's idea, and it was essentially a grate or a type of bag at the bottom of a recycling bin that would be able to filter out the small plastics so that those didn't end up being sent to the recycling plant when they need to be. And this was the connectable plastic products, which there were 3 variations of. There were connectable forks that we ended up going with, of course, and those would prevent the forks from being sent to the landfill because when they're consolidated into one, they will be properly recycled. Very similar idea for pill bottles. We wanted a way to attach them to each other that would make it so that they didn't end up in the landfill. And very similar idea for like sauce cups that you often get at restaurants that also end up in the landfill.
So to narrow down these 3 ideas, we created a decision matrix. This included our main target areas, which was safety, cost, complexity, consumer opinion, ease of use, and solution effectiveness. At first, our solution 2, which was the filtering recycling bin, and solution 3, which was the connectable plastic products, ended in a tie. So we revised our matrix. This time we added a component that would which rated the overall ability to tackle the overall problem. And so this resulted in concept 3, which was the connectable plastic products being our final concept.
Now that we've had our solution, that we have brainstormed and we had a couple of drawings of, we need to figure out how to best go about creating it. It's kind of a unique solution compared to a lot of EDD groups, simply because it's not a single product, but it's kind of like a family of products that we can create in different models and have different design aspects to them. So we want to make sure that we were able to divert enough time to each one of them and make sure that we are very quick in our process to make sure that we have the things that you see up here today.
So our first attempt at prototyping, this was our initial design for the fork. We did experience a lot of difficulty though, because as you can see right here, this has had 3 of the 4 prongs broken off. When we printed them, the print wasn't very strong and it caused them to break along those axes. And the prong part of the fork was also a bit too curved to allow us to stack it together well. And for the pill bottle connector, we had just a little bit of trouble with it being slightly too loose. It could endure like about a medium amount of force put on it, but we still wanted to make it even better.
So our second attempt at the fork was a change in the way we printed it. So we split the fork down the middle vertically and we printed it like that, which worked at first, but the glued centered stitch would not handle much force. So when we tried playing around with it and seeing if it would work, it felt hard. So our third attempt was a complete redesign. We used a slide and clip mechanism, and it worked with sanding and love. But with when we put the forks together, we realized we only dimensioned it for 2 forks to fit together, which was a problem since we wanted a lot more forks to fit together effectively.
So in our final design, we were able to increase the thickness of the threading on the pill bottle connectors. And we also, for the consumers, we added a little bit of lettering in the actual connector. I don't know if any of y'all can see in here, there's like a little bit of lettering just to make sure, because it does look kind of the same from both sides. So we want to make sure that the people using it are able to use it successfully. For the forks, we made the change. We created a new geometry that allowed an infinite amount of forks to be stacked together so they could fulfill the purpose of being recycled successfully together. These 2 different designs kind of showcase a different style of the engineering design process in terms of how we went about it. In the pill bottle, we found early success. We were able to get a solution to work right away, but we focused more on the way that the consumers interacted with the product in order to make it better, to improve upon it. For the fork, it was a much more mechanically difficult design. We had to go through many variations of it to try and figure out what's the best way to get it to successfully work and clip together.
So, all in all, we are pretty satisfied with our project. We did experience some highs and lows. Like Mark said, the fork was rather challenging to create so that we could stack multiple, but also in a way that it was sturdy enough to withstand the amount of force that happens and these forks are put under at like recycling plants. Sorry, this all true. And we also had a bit of a hard time with our printers, but other than that, we had a lot of successes too. Like he said, the pill bottle, we had some earlier successes, and I feel like we worked really well as a team. We didn't really have any conflict, and I'm just really glad that we were able to have such a good team dynamic, and I think that that even enhances the quality of our project.
So we're excited. Thank you so much for your time and having the presentation.
Just a general comment, the plastic is the environment, the impact is going to be so great over the years. And I hope you keep this passion and you will find, the pollution side, the health on the individuals, and you heard about the phthalate in soft plastic that causing maybe up to a third of heart problem. The microplastics that we inject into our brain, and who the hell knows what's doing to us. The plastic in the ocean, the effect on animals, and it's driven by big industry, big oil industry, big, huge corporations, Dow and so forth. And they play with the people, or they're recyclable. They're not recyclable. We have hundreds of different plastic you cannot put together. You address some of these problems. So I just want to keep the passion and your future adult professional life, you'll tackle the problem of plastics.
Thank you. We actually talked, while talking to Ms. Rifkin, we asked her about what she saw in the future of plastic recycling. And even though she works at the head of a plastic recycling plant, she wishes that in the future she wouldn't need a job. That what she does is something of the past, that we no longer use plastic in the future, and that we tackle the heart of the solution instead of just the trimmings. Thank you.
What was the most frustrating part of the process for you guys?
I would say the prototyping process. I think it's one of the biggest challenges in engineering is being able to like see something in your mind and put it into reality, and then have to face that it's not going to work the first time you do that. We had, I believe, 6 different versions of the fork in total that we had to like sketch, draw, 3D model, print, and then test. So going through that 6 times is definitely something that you really hope that it works a 6th time. They don't have to go through a 7th, but it's just about making sure that you learn from the previous mistakes of the previous version and making it as successful as you can in the next version. Not letting that get to you.
I would say for me, the most frustrating part was definitely the proposal writing. Because it's easy to come in here and to have all of these thoughts and learn all of these things and work hard, but it was hard to put that all onto paper, to put all of our knowledge onto paper, to put all of our thoughts onto paper. But it really is such an important thing for us because as aspiring engineers, communication is very key. So just knowing that it was a necessary part was kind of what got us through that. But I would say there was a lot of frustration that came through with all of the detail that we were going into and how much we had to express through our writing.
Good.
Well, I have one question for you. Did you, during your research, did you compare US to other countries and how we are doing as US? Can you comment on that?
I don't remember the exact statistics. We have it somewhere. It actually might be
It's in the
in
binder.
that binder that's being thrown around right now. But yes, the US is in like the top 2% least efficient countries in regards to recycling. So that not well.
And why do you think that's the case?
I think it's because we have access to so many things quickly. We have fast fashion, which is like plastic clothes just being very accessible. We have a lot of plastic things very accessible. You think about fast food, everything's plastic. The more accessible things are, the less sustainable they tend to be. That's a trend that we've seen. And I think that that is a very big contributor as to why America isn't doing as well with recycling. And also regulation. Like most countries in Europe have far stricter regulation on what can be recycled, what can't. And so they're much more efficient with their recycling because they have more regulation on it.
I think the level of care is also different in other countries because the people learn to like, oh, there's this many recycling bins, all different for different types of materials, and they do it because they care. Here, you see that you don't see people care that much about like what they throw in the trash versus what they throw in the recycling bin. So there's a lot of different answers to that.
So are the engineering technical process solutions the best way to attack the problem here? Or is there anything that you can think about besides engineering technical solutions?
I mean, there's very many ways to attack the problem. I do think that it needs to be an industry side change or governmental regulation change because like I said, Europe, far more efficient, but far more regulation on it. And we've seen a direct correlation between regulation and efficiency. So we haven't tried, so we don't know what's going to be more effective. We don't know if it would be more effective to replace plastic or to try and regulate plastic more. We don't have that information.
All right, thank you.
Thank you. Who's the next group?
Next group.
Thank you.